This is the 2007 map, and using the outcrop patterns we can see several key features. The first being the Pluton, which is a circular outcrop pattern that's discordant to the bedding, as well as a dike that is coming from the Pluton itself, which again is sheet-like morphology and discordant to bedding. There are several layers which are horizontal, rock unit B and D, and these are different to the layers down here, which both show evidence of a fold with diverging dip. So this boundary which we have here must be an unconformity, because we've got a change in dip amount and dip direction. The layers below the unconformity are older, and I know there's a fold there because this layer is not repeated, but these two layers are on either side, and so are these here. I know it's an anti-form because both of the units on either side are dipping at 45 degrees away from each other, and even though there isn't a dip direction symbol in both rock unit E here, because they've got the same outcrop pattern, the same trend as the ones which do, they must also have a 45 degree dip as well. So I've got an anti-form axis in the centre here. Okay, now we've made our interpretation, we need to start to do our cross section. So first bit is transfer the information that we've got from the map onto our piece of paper, label things up X and Y, and then key features that we can see. So as usual, faults are long lines to identify where they are, and our intrusion at the top end. Now this is the interesting feature. All the rocks that we've got here at the surface are all rock unit B. Now the examiners can't get us just to put two rock types on and 2 faults, so there must be something more going on to do with features below the unconformity. Another interesting feature to note down here as well, rock unit B closest to F2 is horizontal, but as we get towards the Pluton it starts to tilt towards Y at 35 degrees. And if we look, we've got a radial change in dip direction around the Pluton, so the Pluton is pushing up the sedimentary layers around it as it's intruded. So it'd be an interesting feature to mark down on our cross section. So I'm just going to put 35 degrees here. I'm just going to put horizontal in the middle. Okay, right, so before we go on any further, we need to sort of work out the order in which we're going to do our cross section. The first one that we're going to put in, if we have a look at it, is the Pluton, because it cuts across the unconformity as well as the fault F2, and the faults cut across the unconformity and the folded layers as well. So I'm going to put in rock unit B first, rock unit A first, because that's the Pluton. Because the faults cut across the unconformity and the folded layers, they will go next. And looking up here on the map, I can see that F1 is older than F2. So I'm going to put F2 in first, then F1. Then I'm going to put the layers above the unconformity, which is rock unit B. And then I'm going to do the folded layers below the unconformity at that point there. Okay. So let's transfer the information that we do have first onto our cross section, and then we'll worry about what's happening under the unconformity afterwards. So we're going to line up X and Y. First layer that we're going to put on is rock unit A, and the outcrop tells me it's going to be there. Remember, our convention is our Plutons are steep-sided bodies. If they're at X, they're going to tilt towards Y. So, and I know it cuts across everything, so towards the surface and down. and mark on rock unit A straight away. Now the next boundary we're going to put on is F2 and F1. Now to look at the map to work out what angles they are. Well, if I look here, F2, which is the first one to put in, is a straight line, so it's vertical. F1 is wiggly, so that suggests that it's dipping. And in fact, I've been told in the exam paper that it's 75 degrees towards Y. So let's mark those on next. So F2 there, F1 here. So F2 is vertical, which is this fault on here. So I'm going to put a vertical line. I know it cuts across the unconformity, so I'm going to extend it up into the air and take it all the way down here. F1, let's label it up so I don't forget which one it is. F1 is here and it is dipping 75 degrees towards Y. So there it is. I know it's extended up into the air. Let's label that up as F1. Okay, right, so we've marked in A, we marked in F2, F1, we need to do B. Now, they've given us sections of B on the cross section already, and let's see where they got those numbers from. Well, on here we've got spot heights, these little triangles, that tells us the height that the unconformity, or the boundary for base rock unit B is at. This side here towards Y is at 225. And if we have a look on the cross section, that is that height there. Okay, and double check on this side, it's got this down at around about 175. And look, there's a spot height here. So the base of rock unit B in between F2 and F1 is at 250 metres. So using a long ruler, I can put the base of rock unit B in there. This is B on top. Take that across to the faults. This one here, and we know that it's going to tip 35 degrees from this side here as it gets closer towards the intrusion. So what I can do is just tip this up a little bit from that point there. Okay, right, so we've done the straightforward part. Now we need to work out what's going on below here on these sides of F1 and F2. The bit that we know most about is this section here on the map, and like you've been shown before, you can predict where these boundaries were before the unconformity covered them up. So if I take this and project it underneath the unconformity, it would hit the line of cross section there. Same for that one, and same for this one, and same for that one there. So this would be rock unit E. This is rock unit D in the centre, and this thing here is rock unit F. So on your two-liner section, you can mark those off. We know there's going to be a fold axis down here, which is an antiform. They go 45 this way, and they go 45 away from the APT there. So let's mark those on. We do this section first, as I said, because we know more about this than any other part of the map. So that hits the base of the rock unit B at the unconformity. And I'll mark on what the letters are in a second. We know this is going 45 degrees towards X, which is over there. Get stopped by the fault. Okay, that's a key thing that you have to remember. It's been stopped by the fault. We know that because we can't see the pattern on the other side. All we get is rock unit, the stipply one. This side over here, 45 degrees in the other direction. Okay, let's make sure I know which letters go where. So D in the centre, E, and then F. So D, E, F. In fact, I can put my full axis in because I've got equal angles on either side. I know it's got to be vertical, and I know it's an anti-fall. Okay, we're very close to finishing. Now we've got faults on either side, and we've got these parts to fill in. We know this side has gone down relative to this side because boundary B has dropped there. It's higher up on this section, and similarly on this side's higher and this side is lower, just from using rock unit, base of rock unit B. Now we need to finish off this section here. Now we can actually work out how much the fault has moved down by measuring the vertical displacement. So on here, on my measurements, it is about 1.5 centimetres. So this is the top of rock unit E. This boundary here has got to move down 1.5 centimetres. So it would be on this side about that angle. Move this down here, keeping the same angle as what I've done up here. That's rock unit D, and all this is rock unit F in there. This side I'm going to use the same technique again. Notice I'm using the vertical displacement, not along the fault, it's vertical displacement, which is the throw, and that is 4 millimetres. So this is a little bit harder because the fault's dipping, but you do best you can. So this boundary here is 4 millimetres down along the fault there. So that's 4. So it's going to be at this point here. Again, this is a quicker way of doing it. You could measure 45 degrees out. I'm going to do it this way, it's a bit quicker. One more to put on, 4 millimetres down vertically from there. There's 4, let's move it across a little bit. So it's this point that we've got here. So I'm going to move that down onto this section there. So this is E, this is D. I think we're finished. We've labelled up the fold axes, we've labelled up the faults, we showed arrows to show the movement, and we've labelled up every single layer on the cross section, and we've shown our displacement along the faults. We've done.